Good morning, students. So now we discuss design and analysis of algorithms, first unit. Okay, so first unit is the introduction of algorithms. See, so what is an algorithm? So algorithm is a finite set of instructions that can be accomplished by a particular task. So task means whatever, it may be program or anyone. Okay, so algorithm is a finite set of instructions that can be accomplished by a particular task. Okay, and what are the properties of an algorithm? There is a 5 properties. The first one is input, second one is output, third one is definiteness, and fourth one is finiteness, and fifth one is effectiveness. These are the 5 properties of an algorithm. So what is meant by input? So input is 0 or more quantities are externally produced. Okay, that is 0 or more inputs externally produced. Okay, why we say 0? Because of printf is a hello world. If there is no input, the output is hello world. So in that way we can say that there is 0 or more inputs are externally produced. And what is output? Output is at least one quantity is produced. It is called as an output. Okay, and definiteness is at least, like, each and every instructions must be clear. Each and every instruction must be clear. It is called as a definiteness. And finiteness, every instructions must be ended with any one of the part. It is called as a finiteness. And effectiveness, every instructions must be very basic and enough to write with only paper and pencil. That is, we can efficiently perform the algorithm. In that way we can use performance analysis, that is the time complexity and space complexity, we can use to perform the effectively we can produce the algorithm. So these are the 5 properties of an algorithm. First one is input, output, definiteness, finiteness, and effectiveness. Okay, so the study of algorithm includes many important and active areas of research. The 4 important active areas are: the first one is how to devise algorithm, how to validate algorithm, how to analysis of an algorithm, how to test algorithm. So here we can use the 4 active areas. The first one is how to devise, how to validate, how to analysis, and how to test. See, how to devise. Mastering device techniques are used to devise new and useful algorithms. There are some important device techniques are used. The first one is the dynamic programming, linear programming, non-linear programming, and integer programming. Okay, these are the 4 important device techniques. First one is the dynamic, linear, non-linear, and integer programming. See here, we can implement new and useful algorithms based on the different type of techniques. Okay, that is the different type of techniques are dynamic programming, linear programming, non-linear programming, and integer programming. Next, how to validate an algorithm. See, once an algorithm is devised, it is necessary to show that it computes the correct answer for all possible legal inputs. This phase is referred as an algorithm validation. So when the algorithm device is completed, then we go for the validation. In that validation, we can give the different type of possible legal inputs, then we can compute the correct answer. It is called as the validate, that is algorithm validation. Once the validity of the method shows, a program can be written and second phase begin. This phase is referred as a program proving or verification. Okay, when the validation is completed, the next phase begin, that is the verification. Okay, and third one, how to analysis of algorithm. That is, analysis of algorithms or performance analysis refers to the task of determining how much computing time and storage an algorithm requires. That is, how much computing time, that is time complexity and space complexity we have to use, and we can analyze the algorithm. Okay, so analysis of algorithms or performance analysis refers to the task of determining how much computing time and storage an algorithm requires. Next, how to test algorithm. Testing of program consisting of 2 phases. The first one is the debugging and second one is the profiling. So debugging is the process of executing programs, and profiling of performing the measurements is the process of executing a correct program. Here we can use the four types. First one is the how to devise algorithm. In this devise algorithm, we can create and implement a new algorithms using different type of design techniques. There is a dynamic, linear, non-linear, likewise. And how to validate. So we can use the different type of possible legal inputs. Then we can compute the particular algorithm, and then when the validity is completed, the verification is start. And how to analysis of algorithm. In this analysis of algorithm, we can using the different type of computing time and storage algorithms required. Here we can use the time complexity and space complexity. And how to test algorithm. Testing of a program consisting of two phases. First one is the debugging and second one is the profiling. See, debugging is the process of executing programs. Profiling of performing measurement is the process of executing a correct program. Okay. Next, algorithm specification. Here you can go for the pseudocode. So what is meant by pseudocode? Pseudocode is an informal high-level description of a computer program. It is written symbolic code which must be translated into a programming languages. Okay, how we can give the convention? See here, the comments begin with backslash and continue until the end of the line. And second one, a compound statement can be represented as a block. That is, blocks are indicated with matching braces, open and closing braces, and the statements are delimited by, that is, the end of the statement we can use the semicolon, and identifier begin with a letter. And assignment of values to variables is done using the assignment statement, that is the variable colon equal to expression. Likewise we can assign the assignment values, and there are two boolean variable values, that is the true and false, and logical operators and or not, and relational operators are less than or equal to, greater than or equal to, not equal to. Okay, and the following loop statements are employed. The first is for, while, and repeat until. See, when while loop, while condition do the open the braces statement, and also and to the statement n. Okay, so likewise we can use a different type of looping statements. It is the structure of the loop. And go for the for loop. For variable equal to value 1 to value 2, that is the step 2. Then here step 1 and so on step and repeat until 2, statement of 1 and so on statement of n until the condition. You can also here is the using to the for loop. A conditional statement has the following forms, that is if condition then statement, then if condition then statement minus 1, else statement 1. Okay, if you go for the case statement, case like condition 1 statement and so on condition n statement, and else the statement of n plus 1. So likewise we have to go for the conditional statements. Okay, next, input and output are done using the instructions read and write operations, and there is only one type of procedure, that is an algorithm. The heading takes the form of the algorithm name. Name is the algorithm name of parameter list and open braces and close the braces. So likewise we can assign the algorithm, that is algorithm and name of the algorithm within the braces, parameter list, open parenthesis and close the parenthesis. Okay, see for example, algorithm max of a comma n, that is a is an array of size small n, then return that then result equal to a of 1, that is the first element is the maximum element, it will be the result. Otherwise you go for the condition for I equal to 2 to n, do if a of I is greater than result, then print result equal to a of I, then return to the result. See here, algorithm max of a n, that is we can print the maximum element of an array. So a is an array of size of n, then result equal to a of 1, that is a of 1, the first element is the maximum element, then it will print the result. Otherwise it will be checked, that is I equal to 2 to n, if a of I is greater than result, then result equal to a of I, then return to the particular result. So likewise we have to write the algorithm. Then recursive algorithms. What is meant by recursive? A function call itself is called as a recursive function. See, a recursive function is a function that is defined in terms of itself. Similarly, an algorithm is said to be recursive if the same algorithm is invoked in the body. So an algorithm that calls itself is a data recursive, an algorithm A is said to be indirect recursive if it call another algorithm which returns calls A. So for example, we go for the towers of Hanoi. Okay. So what is mean recursive? Recursive is a function and it call itself. Okay. So in that way we can assign the two type of recursive functions, that is a direct recursive and indirect recursive. An algorithm calls itself, it is called as a directive. An algorithm A is said to be indirect and it recursive call as the another algorithm which in turns calls A, that is called indirect recursive algorithm. Okay. See here example, the towers of Hanoi. Algorithm tower of n comma, that is equal to n equal to towers and A comma B comma C, and A is the source, B is the mediator and C is the destination. So here we can moving the number of disks from A to B. See for example, if n equal to 1, then move disk from A to B and return. If not, if the n equal to more than 1, then the tower of n minus 1 comma A comma C comma B, and write move disk from A to B and tower of n minus 1 comma C comma B comma A. Here we can use A, C, B is the, it may be source, intermediate, destination, or source, intermediate, destination. Okay, it will be changes at the time of the move from the disk from one source to another. Okay, so algorithm tower of n comma A comma B comma C, n is equal to number of disks. If n equal to 1, it move from the A to B. If n equal to more than 1, then go for the n minus 1 comma A comma C comma B and write move disk from A to B and tower of n minus 1 C comma B comma A. And go for the performance analysis. Here we can use the two types of complexities. The first one is the space complexity and second one is the time complexity. So what is the space complexity? Here the space complexity of an algorithm is the amount of memory it needs to run of a compilation. That is how much memory is required to store a particular algorithm. The space needed by a program has the following components. See here, first one is the instruction space, second one is data space, third one is environmental stack space. So what is meant by instruction space? It is the space needed by the compiled version of the particular program instructions. It is called as the instruction space. So what is the data space? Data space is the space is needed to store the constant variables like constants and variable values. It has the two components. First one is space needed by the constant and second one space is needed by the dynamical allocated object, that is called as a arrays. Okay. And space is needed by each of the algorithms or some of the fixed part and variable part. And here we can assign the two types of parts. The first one is the fixed part and second one is the variable part. A fixed part that is independent of the instance characteristics. This is part includes instruction space, that is the space for code, space for simple variables, space for constants. It is called as a fixed part. And variable part consists of dynamically allocated and recursively stacked space, that is it will not dependent. Okay, see here the space requirement of an algorithm P may be written as S of P equal, there is a S of P equal to C plus SP. So for example, algorithm sum of A comma B comma C, that equal open braces return A B C. Here the space needed by simple variables A, B, C are independent and the instance characteristics, therefore S of P equal to 0. Why S of P is equal to 0? Because of the variables not depend on other variables. In that way we can say therefore S of P equal to program for space equal to 0. Okay, so here two parts, first one is the fixed part and second one is the variable part. Next, time complexity. The time T of P taken by a program is the sum of compile time and the runtime. So that means how much time is required to run a particular program, a particular algorithm. It is called as a time complexity. See, the compile time does not depend on the instance characteristics. Also, we may assume that the compiled program will be run several times without the recompilation. This runtime is denoted by the instance characteristics. Okay, so the number of steps any problem statement is assigned, it will be depends of the different type of kind of statements. For example, comments like as 0 step, assignment like as 1 step. Okay, see here you can use the two type of methods. The first one is the step count method and second one is the frequent table method. So consider global variable count and initialize 0 each time of a statement encounter. Then count is incremented by number of steps of the statement. See for example, algorithm sum of a comma x, that is s equal to 0 and count equal to count plus 1 for I equal to 1 to n, open braces, count equal to count plus 1, s equal to s plus a of I, and count equal to count plus 1, like count equal to, see here, count equal to count plus 1, then s equal to s plus a of I is the I equal to 1 to n, the a of I is the depend upon the n variable. So here in that variable it will be take to the 2n times. See here, outside of the loop the values increment, that is each time of the count will be incremented 3 times, and inside of the loop here, that is this loop will be incremented by 2n times because of count equal to count 1 plus s equal to s plus a of I. A of I is dependent upon the n, so that is equal to 2 into n. Therefore the t sum of n equal to 2n plus 3. Okay, this is a step count method. So here you can assign the number of steps is incremented by, or number of steps will be used into the particular statement. Next, frequency table method. In frequency table method, first we determine the number of steps for execution of the statement, and frequency of each statement is executed by combining to the two quantities. See, for example, algorithm sum of a comma n, open braces, s equal to 0 initialization, and for I equal to 1 to n, then s equal to s plus a of I, and return s. See here, step for execution, frequency, and total number of steps. So step for execution of the statement, that is s by e, and frequency, that is total number of steps, how many times that step will be incremented. See here, algorithm sum of n is a step for execution 0, open parenthesis also 0, close is also 0. So initialization equal to 1, then for loop is 1, and s equal to s plus a of I equal to 1, and return s equal to n. That is the each and the number of, that is the execution of each statement is the one time. But frequency means how many times the number of steps will be counted. Here s equal to 0, 1, for I equal to 1 to n, that equal to n times, and s equal to s plus a of I, it is also n times. But here we can assign n plus 1 times. Why we can assign the n plus 1 times? Because whenever for I is n equal to 6, so it will be check 1, 2, 3, 4, 5, 6. At the time it will not be terminated. The next step it will be checked. In that way we can assign the n plus 1. Okay, so 6 steps will be completed, then it will be checked from the n value. So n is more than 6, it will be terminated, and it from the s equal to s plus a of I. So in that way 1 is for I equal to 1 to n is n plus 1, then s equal to s plus a of I equal to n, and return equal to 1. Therefore 1 n plus 1 n 1, that equal to 2n plus 3 times the particular statement will be executed. So in frequency table method, first we have to determine the number of steps of execution of a statement, and frequency, that is the total number of steps of each statement is executed by combining of the two quantities. Okay, and depending on passing size of a problem, a step count methods are classified into three types. The first one is the best case, average case, worst case. So best case is the minimum number of steps the particular problem can be executed, and average case, the average number of steps will be required to solve the particular problem, and worst case, it will be maximum number of steps it will be taken. In that way we can assign the three type of cases. First one is the best case, that is the minimum number of steps required. Average case, average number of steps is required. Worst case, maximum number of steps are required. Okay, so depending on passing size of the problem, step count methods are classified into three types, that is the best case, average case, and worst case. Then go for the notations. To choose the best algorithm, we need to check the efficiency of each algorithm. when we have to produce the best algorithm, first of all we can check the efficiency of the particular algorithm. Okay, the efficiency can be measured by the computing the time, the complexity of an algorithm, that is asymptotic notations we can use it. That is, asymptotic notation is a shorthand way to represent time complexity. There are three types of notations. The first one is the big O notation, second one is the omega notation, and third one is the theta notation. See, the function f of n equal to big O of g of n, that is if and only if there exist positive constants c and n naught such that f of n is less than or equal to c into g of n for all n comma n greater than or equal to n naught. And go for the omega, the function f of n equal to omega of g of n if and only if there exist positive constants c and n naught such that f of n is greater than or equal to c into g of n for all n comma n greater than or equal to n naught. Theta, the function f of n equal to theta of g of n if there exist positive constants c1 and c2 and n naught such that c1 into g of n less than or equal to f of n less than or equal to c2 into g of n for all n comma n greater than or equal to 0. It is upper bound, lower bound and average. Okay, so big OH, big omega and big theta, these are the three types of Esther notations. It is the represent to the time complexity of the particular notations. Okay, see, this is the first part of the algorithm. Okay, see here. So first one is the introduction to algorithm. Next, algorithm, here the five types of properties: input, output, definiteness, finiteness and effectiveness. And next one is the different type of areas, that is how to devise algorithm, how to validate and how to analysis and how to test. And next one is the algorithm specification. Here you can go for the pseudocode conventions and recursive functions. And next one is the perform analysis. Here two type of performance analysis. First one the space complexity and time complexity. In space complexity, how much memory, how much space is required to store the particular data, and time is how much time is required to run a particular algorithm. These are the three types. And time complexity, we can use the two types of methods. First one is the step count and frequency table method. Okay, and based upon the size we can use the different type of cases, that is the best case, average case and worst case. In best case, the minimum number of steps is required, average number of steps are required, and maximum number of steps are required. Okay, and we go for the asymptotic notations, is a shorthand way to represent the time complexity. Then there are the three types of notation. The first one is the big O and omega and theta. These are the three types of asymptotic notations. Okay, thank you.